Welcome to Ratio and Proportion, Unit 3. We're done with kinda two-step equations for a while. Make sure you complete the welcome work before starting notes. If you haven't done that, stop the tape now and start again when you've done it, when you've completed it. This drawing is kind of a hint as what we're talking about, ratio and proportion. These are all the same size guy. They're just different proportions, right? Different ratios. I thought I was cute because he had a shoe on that guy, and this guy had a shoe on that guy, and this guy has a shoe on that guy. And that's sometimes how I felt when I was in middle school. Everybody's got a shoe on you. All right, here we go. Here's our answers for our welcome work. Janice can complete 7 toe touches in 10 seconds. A ratio, if you're writing a ratio for that, ratio just means fraction. Ratio means fraction. So 7 in 10 seconds, 7 over 10. Another way to write that would be 7 colon 10, or just like you say it, 7 to 10. But basically, we're all talking about a fraction. This whole unit's about fractions. So a ratio, 7 over 10. This is 3 ways to write a ratio. 7 over 10, 7 colon 10, and 7 to 10. You're going to see that over and over and over. So let's complete the following table representing her toe touches. Well, in 0 seconds, she can do 0 toe touches, right? And in 10 seconds, she can do how many toe touches? You got it. We'll look at this table. Here's her toe touches. I've already plotted those for you. So in 10 seconds, she can do 7, which is what they told us, right? That's just the information they gave us. 7 toe touches in 10 seconds. So in 20, she can do 14. You got it. You got this already filled out. In 30, she can do 21. In 40, she can do 28. What about 50? 50, she can do 35. What about 60? 60, she can do 42. And all I did was show the ratio or proportion. It's going up in a straight line. They ask you to plot those points. Remember, every good graph has a label. I'm going to put time in seconds on the bottom and toe touches up the top. And as we know, a little refresher, you're safe if you go left to right first. So you go side to side first, up and down. So 10, 7, 10. You start here, go over to 10, and then 7. And this one you start, go over to 20, go up 14. So you're going this way first, and then this way. That's the way it's going to be for X, Y forever. Remember plotting points, making pictures. That's a graphic point, right? X, Y. You do X first. You go this way first. Then with Y, you go this way. So all we do is plot your points. If you have a nice little even graph there, you did it perfectly. All right. Write an algebraic expression. The cost of each ticket, if X tickets cost, so the total is 106. How would I figure out how much those tickets cost? Well, what if there's 10 tickets? What if there's 5 tickets? I would just divide those, right? The total is this. We want to know how many each ticket costs if we have X tickets. What about gas? Same way. Cost of G gallons if each gallon costs this. If each one costs that, we don't know how many we're going to have. You got it. I know you got that one. And the last one, we're getting so great at these. 5 less than 3 times the number. 5 less minus 5, 3 times the number. Hopefully got those all correct. All right, let's take out our note packets. Here we go. What we're going to be doing in this unit, in this first 2 sections, we're going to express, which means like write, relationships using ratios. And we're going to find unit rates. And a unit rate simply means how much is 1. If I told you 10 of them cost $10, how much would 1 cost? $1, right? This is a great problem. Interesting sports fact, and this is actually true. There's only 2 days of the whole year where there are no professional sports games on NBA, MLB, NHL, NFL. It's the day before and the day after the Major League All-Star game. Football's out of season. Basketball's out of season. Hockey hasn't started yet. So the only day, and think about it, they play games on New Year's, Christmas, everything like that. We're going to write a ratio of those. Compare the number of days with no events and the number of days without events. So here's our 3 ways, remember? We can write a fraction this way, or a ratio this way. We can write a ratio that way. And we can write a ratio that way. And when I say ratio, put a star by this. It just really means the word you're comparing two things, right? And a rate is like miles per gallon, right? That's a rate. Miles per gallon. But really all we're doing, we're talking about fractions. So it says write a ratio in all three forms to compare the days without games to days in the year. Well, how many days are there in a year? 365, right? How many days are there no games? Well, we told you there's only 2. 2 days without any games. So to write that 3 ways, 2 to 365, 2 to 365, and 2 to 365. Notice they sound the same, even though they all say the word 2. So this one, hopefully you wrote it 3 ways there. What ratio compares to days with games? Well, there's 365 days in a year. If there's 2 days that don't have games, the rest of the days are what? You're right, 363. So the rest of the days do have games. 363 to 365, 363 to 365, and 363 to 365. I know, this is easy, right? I know you got it. All right, let's keep going. Hold on, let me take a sip. All right, unit rate. Unit rate just means 1. A unit rate is expressed as 1 unit. You're going to hear the word unit rate, but it just means 1. That's why I got the little 1 guy here. Let's do a sample problem, and I bet you got it. Suppose you and your friends attend a basketball game. Going to a game, right? You buy a block of 8 tickets, and they cost $192. So you get your Visa statement. It's $192. How do I figure out what 1 ticket is? When I say shoe, press pause, see if you can figure that out. Shoe! Welcome back. Rate 1, uno, a single unit. I bet you got this right. 180 or 192 divided by 8, right? If all the tickets cost 182, how do I figure out what 1 ticket costs? Divide it. It's $24 per ticket. Notice how I got the word per ticket on there. In this unit, you're going to see a lot more labels on your answers because all the problems have kind of story-related problems, especially when you talk about a unit, which means 1. 1. Unit rate. 1. All right. Let's do some problems together. I'm on page 81. There are 9 position players on a baseball team. 9 people on a team. And here's how it goes. You got 1 catcher, 1 pitcher, 4 infielders, which means first, second, third base, and shortstop, and the 3 outfielders. If you add that up, 3 plus 4 plus 1 plus 1 equals 9, right? So what's the denominator in our fraction going to be? 9, right? Oh, sorry. Only if we're talking about the whole team. Skip that. Infielders to number of players. Well, how many infielders are there? 4 out of 9, right? 4 out of 9. Go ahead and complete these. When I yell shoe, press pause, complete these, then come back. Shoe! Welcome back. Here we go. We did the first one for you, 4 to 9. Could I have written that as a fraction like this? 4 to 9? You betcha. You betcha. B, 3 to 4, right? Number of players, or outfielders to infielders. There's 3 outfielders, 4 infielders. So I'm just putting them in order the way they say. Number of players to number of outfielders, well, 3 to 1. There's 9 players and there's 3 outfielders, right? And they just reduced that fraction. So you might have had 9 over 3 on your paper, but you just reduce that fraction, you get 3 to 1. Number of players other than outfielders, infielders and outfielders to the number of players, 2 to 9. Number of pitchers to numbers of catchers, well, there's 1 pitcher and 1 catcher. So that ratio is 1 to 1. When I say shoe, figure out number 10, the unit rates, right? Remember, you're dividing the total to get a unit rate per thing, per item. Shoe! Welcome back. Number 10, unit rates. 162 divided by 9. One ticket costs 18, right? 1 for 18. 15 and 5, 3 and 1. They just reduced that fraction. You have to get it to a single unit. Unit means 1. 18 and 14, 6 to 1. 24 and 12, 2 and 1. You're getting it to 1 unit rate. 1 unit. I bet you aced that. All right. We're already at day 2. What we're going to do is we're going to determine whether quantities are in a proportional relationship. And we're going to solve problems involving proportional relationship. That sounds complicated, but it's really not. And I'm going to show you a neat trick. So it says the fastest time for running a mile while balancing a baseball bat on your finger is 7 minutes, 5 seconds. I'm not even sure why someone thought that that would be a good idea to try to break that record. That's crazy. This record was set by some girl on June 20th, 2009. At that rate of speed, Meg predicts it would take her 1,275 seconds or 21 minutes, 15 seconds for her to run 3 miles. Is she right? Is she right? It's a unit rate, right? I would get into some unit we could all agree on so you can compare minutes to minutes. But basically, it doesn't matter what you do as long as you compare the same thing to the same thing. What if you put the wrong one on top? It doesn't matter if you put it the same on both sides. So this time is for what? She's got 7 minutes and 5 seconds. And that was running 1 mile, right? And here's 21 minutes and 15 seconds for 3 miles. Well, 1 times 3 is 3. Is that equal? Is 7 minutes and 5 seconds times 3 equal to that? Yeah. 7 minutes times 3 is 21 minutes. 5 seconds times 3 is 15 seconds. So that's a giant yes. She's right. Those are proportional. All right. The word proportion is just an equation stating that 2 ratios are equivalent. So we're talking about equal fractions. Equal fractions. Are the fractions equal? Equal fractions. And you want to know a great way to do this? You're just multiplying. So here's my proportion. I got 2 over 5 and 10 over 4, or 4 over 10. We're going to multiply. 10 times 2 is 20. 5 times 4 is 20. They're equal. That's how hard it is. You cross multiply. So what the problem they did, instead of like seeing, we went 1 times 3 and this times 3. In this one, they're converting the seconds. So they convert 7 minutes and 5 seconds into 425 seconds. They convert the other time into 1,275 seconds. And then they multiply. They multiply this one, and they multiply this one. Are they equal? Yes, they are. 3 times 425 is 1,275. And remember when we did fractions? That's why this works. This is how we learn fractions, so this is going to be a breeze for you guys. But cross products, remember? You're just multiplying across. Cross multiply. All right, math tip. I got my little guide that we're calling any proportion. If it's a proportion, the cross products, meaning the multiply like that, they'll be equal. Okay, I'm on page 83. We're going to cross multiply. Let's do these. I'll do the first one for you, then I'm going to yell shoo, and you're going to do B and C. So I'm going to cross multiply. I'm going to multiply this way and this way. I'm going to get 0.35n. And on this side, I'm going to get 2.45. I'm going to divide this side. Same. I bet you thought we were done with that. No, we're not done with that. Same. Is that equal? Let's see. N equals 7. N equals 7. I solved for n, right? Those cancel each other out. Divide that out. This number goes into that number 7 times. All right. Do B and C. Shoo! All right, welcome back. Did you cross multiply? 2n and that. You should have multiplied those across. Solve for n. So I multiply, solve for n equals 58.5. Same with C. I cross multiply, solve for n, same. N equals 4. I bet you got all those right. You're great at this now. All right, we'll do a little check your understanding. Use the cross multipliers to determine if they're equivalent. So I'm going to yell out shoe. You're going to cross multiply these, right? 8 times 3 is 24. 6 times 4 is 24. So letter A would be a giant yes. Finish the rest of 6 and then come back. Shoe! Welcome back. How'd you do? B is a no. C is a no. Those aren't equal, right? 7 times 70 is 490. 6 times 60. Okay, 3,600 or 360. Hopefully you multiplied those out and you got those answers. I'm going to yell shoe. You're going to go ahead and write a proportion. So you're going to write just like we did in the last section, just like we did back here. You're going to solve for n, right? So we're going to do that for this. So fill out 7 and fill out 8, and we'll come back and check them. Shoe! Welcome back. All right, there's 336 dimples in one golf ball, and there's 2,016 in n golf balls. You're going to get the same answer even if you didn't set it up exactly. If you put 1 on top and 336 on the bottom, as long as you put n on top and 2,016 on the bottom, you got the same thing. And I bet you did that. I bet you're that smart. You got 6 golf balls, right? Notice I got a label on that one. Okay, B, 3 over 2.8, right? Miles over minutes, solve for x. This one, yards over seconds, yards over some seconds we don't know, right? Solve for y. Cross, multiply, and divide. And you got D, same thing. Heartbeats over minutes, something we don't know, over minutes, right? All right, complete the table for A. Shoo! Welcome back. Well, it tells us right here, zebra can run 40 miles in 1, right? 40 miles per hour. These are hours. So you just got to kind of figure out the ratios there. Should get a 10, a 20, and a 70. How did I figure that out, right? I put time over my distance. And as long as I put time over distance here, right? So I put 0.25 over x, cross multiply. That's how I got the answers for that. Same here, cross multiply, solve for x, cross multiply, solve for x. You got it. All right, have a great day. I know you got this one. Peace out.